Oh, that's so fun. So number 5 in 13.2 is just asking, is this thing a vector or not? Right? And number 5 says the population of the 50 US states. Right, and I'm literally just wondering, is this thing a vector or not? And yes?
Yes.
It means a direction and a magnitude.
And the answer is, I don't know, it depends on your perspective. So what's a vector? Right? A vector should be a magnitude and a direction, right? Okay. But also a vector is kind of the end of a point, or the arrow pointing at a point, right? Okay, so one thing I might think about is, I might really think about this as a point in R50. You guys see like how I could think of it that way?
I mean, all real numbers.
Right, that would be like sort of alphabetizing by state, right? So I'd do like, what's first?
Alabama.
One.
Alabama.
Some starting with an A, and then there's another one starting with an A, and then there's, I don't know, some more.
A few more. I think like
4 A's.
Right, and then like down here at the end is zebra or whatever the last state is. That would be Wyoming.
Okay.
Cool? You guys with this as an idea? Right? And if I think about each of these things, right, into each of these slots is putting a population number, right? So like this one's going to be 1 million, give or take. Yeah, it's, yeah, 1 million's a little high. Actually, it's just over 900,000. There are, in fact, more cattle in Wyoming than there are people, but there are more cattle in Montana than there are people, and Idaho probably. Yeah, whatever. There are lots of states that are very empty. Point is, this kind of thought, right, would give me a point in R50, and the difference in your textbook between a point and a vector isn't a heck of a lot, right? If you've had linear algebra, this question becomes a lot harder to answer because you use stuff like this as a vector.
Yeah. X to the n of the power.
Yeah, so one reason you might use something like this as a vector is you might have a function that does like from 1 year to the next. So this is like population change or something. And that's going to take a point in R50, think about it as a vector, apply this map to it, and get another point in R50. You guys see why it would make sense that that population change depends not just on the state you're in, but also the populations of the states nearby? That's kind of like if you plopped 100,000 people into Reno, right? Some of them are going to leave Reno and come to California because there are cities in California and they'll want to get out of Nevada, right? You guys all see this? So there is some component of nearby state changes, kind of other states, and that's a linear algebra kind of idea. So that function here is a matrix, and that thing takes vectors and outputs vectors. So yeah, kind of.
So
Does that kind of vagary make a little sense?
Yeah, a little bit. I just assumed it was a scalar, and I just wasn't working on why they thought it was going to
Yeah, so the population in each state is a scalar, right? But the whole set of the populations of all 50 states is a list of scalars. And anytime you've got a list of scalars, you might wonder, is there a reasonable way to think of that as a vector? Because there usually is.
is it like, would each individual state be like almost you could break it down as like like into units of like like multiple, not i's and j's and k's, but more than that.
Yeah, yeah, so this would be like,
X1 or,
Yeah.
yeah, so whatever, you'd have whatever, and then your last one might look like plus 1,000,000. Get 1,000,000 there? Yeah.
X50.
1,000,000 x 50,
yeah.
Mhm.
right? Or WY with an arrow over the top of it, right? And then each component of this thing would be the population of some particular state. Cool? That kind of makes sense? What were some of the others there? It was like, oh, okay, so like the population of the US. That's
The sum of all of those.
a scalar, right?
Mhm.
Dimensional vector.
Yeah, which is a one-dimensional vector. Good. Then the distance from Seattle to St. Louis, also a scalar. The temperature at a point on the Earth's surface. Yep, scalar. That's a function of a vector though, right?
Yeah.
Yeah.
You guys see that?
Yeah.
Like, there's a function
Like
that takes the vector
f of
for
x,
pointing
y,
where
z.
you are and outputs a temperature.
F of x, y, z equals 10.
Yeah, exactly. Okay, cool. Other questions? On this one, or a different one?